Hello and welcome everybody. Today we're going to be going over some study guide questions. I just wanted to go basically lesson by lesson and do a condensed video. That way you wouldn't feel like you were stuck watching, 4 or 5, 10, 15-minute videos each. So we can hopefully get some of the broad overview of the skills that we did so far in the last couple of weeks. And you can have a more succinct way to go through your studying and getting ready for our exam. So we're going to start off in 1.1, and this was just kind of taking us back to writing some expressions from word problems and real-world situations. So I'm just going to do one of these, and if you have any questions going forward, just feel free to reach out, email, text, any of those things. I'll be here for you. A reminder, the biggest thing when writing is we have to decide our operation. So are we adding, subtracting, multiplying, or dividing? Once we make that decision, the rest of it is just some annotation and kind of putting some things together. So question number 1, I got my highlighter out because I'm ready to annotate. Really important with word problems that's how we're doing a lot of our engaging here. We spend 15 hours. I'm going to stop. I see a number and highlight it. 15 hours in school each week. That's my unit of time. I'm going to highlight that as well. Write an expression that tells us how much time we spend in school based off of the number of weeks we spend in school. Okay, so basically we're trying to see on a weekly basis how much time are we spending, and then can we use that to calculate a bigger sum off of these weeks. So they don't give us a variable we get to choose here. I'll use W as my variable for weeks. And I have to determine now which of these 4 operations from above do I want to use. So if I spend 15 hours in school each week, am I adding 15 to the number of weeks? So let me think about that in my head. So week number 1, add 15 hours, I get 16. That doesn't work. I don't spend 16 hours in school. Subtracting also doesn't work. Let's try multiplying. So in my head, I'm thinking, okay, 15 per week, kind of like skip counting on a number line here. So go up 15, 15, 15 each week with multiplication. Okay, let's see if this works. So a quick check my work on the side, weeks, and then hours based off of that. 15 times 1, 15 times 2, 15 times 3. Plug these in, see if this works. 15, 30, 45. Yeah, intuitively that works for me, so I'm happy with this. So 15 times W as my expression. I'm good with that. I would recommend checking work, especially on something like an exam. If you do that quick check, you can plug it in and see if what you just did makes sense. Especially something on this that might seem shorter, or I don't want to say simple because it's definitely not with the word problem here, but on a question that seems shorter with a little bit less work to show, I think checking is in your best interest. Next, order of operations. Every single time here, always, always, always PEMDAS. Something that I'll say about these is that if you have, like examples number 1 and example number 4, if you have fractions, there's like an implied big parentheses around the top and around the bottom. So like do the whole top, do the whole bottom, and then focus on the division, because that is technically inside of the parentheses. So again, you're going to want to like do the whole top first, do the whole bottom second. So going through on top, I'm seeing 2 plus 6 as my first step here. So I'll have 3 minus 8 all over 3 plus 2 times, and again, more parentheses on the bottom. 4 minus 2 just gives me 2. Okay, I'm going to keep going, excuse me, on the top, just subtraction, so we're happy. Negative 5. On the bottom, I'm going to do that multiplication first. Keep going. 5 over 7, I'm happy with that. We can leave that as a fraction, that's fine. So again, just going through step at a time, making sure that we're not making any mistakes. And I did put that one first intentionally because I don't think we talked through any of these examples. We might have seen an example like that on the practice questions, but I just wanted us to see, again, do the top first, do the bottom second, and there you are. All right, 1.3. I like these ones. I think they're pretty straightforward, and it's good to show a professional work product form. Plugging in for expressions, my biggest advice to you is use parentheses wherever you see a variable. Put the variable really small underneath it so you don't forget which one it is, and then you're just going through and doing some PEMDAS. So P, putting in parentheses, minus, and I'm rewriting this exactly as it is above. M plus Q. Again, exact rewrite from above. The only difference is that I am taking away the variables, putting in parentheses. So P, matching that up, 5. M, matching that up is 4. And finally, Q, matching that up is 3. Biggest mistake you're going to make on these with multiple variables is plugging in the wrong variable in the incorrect spot. So careful work going through is in your best interest for sure. All right, so PEMDAS time. Looks like I got my first set of parentheses with M plus Q. So I'm going to start off here. So 9 minus 7, and then it's 5 minus 9 minus 7. Okay, more parentheses. Let's keep going here. 5 minus 2. Put that all together to get a final answer of 3. And that's the big idea. It's, again, another application of applying PEMDAS. And then just the difference between this and the last question that we did is your first step is plugging in variables, and then your second step is PEMDAS like we were doing before. Again, any question on these, let me know, but see if you can finish up those remaining examples and you'll be in good shape. Next, I would say probably close to, if not the most challenging skill you're going to see on the test that we're doing here is looking through these word problems comparing expressions. So let's go ahead and take a look at number 1. I got my highlighter out to annotate because it's going to be a hard question. So P and Q are the variables. They represent price of a 64 gig and 32 gig smartphone, respectively. P is greater than Q. So respectively means in that order. So that means P is first, so it's 64. Q is second, so it's the 32 gig phone. Okay, so that's just telling us the size of the phone. So it's saying that P is greater than Q, so I'm going to write this up top here, which makes sense. The 64 gig phone costs more than the 32 gig phone. Okay. Interpret each of the expressions in terms of money and smartphones, then if possible determine which of the expressions is larger. So they want to know which one is bigger. Okay. Express this as an inequality and then explain. All right, so going through, they're telling me that P is greater than Q. That's basically saying that 64 gig phone is bigger than the 32 gig phone. So because of that, I'm taking a big number away with subtraction. So I think this one's going to be small because P is bigger and Q is smaller. And I think this one's going to be bigger. If you think about it, for example, if you plug in a value, P is bigger than Q, 2 is greater than 1. If you plug in 2 here and 1 here, you're going to have 598 and 599. They're asking us which one's bigger, and it's going to be the one on the right. So again, you're taking away a smaller quantity. So you take away less. So because of that, 600 minus Q is bigger or larger. So that's the idea here. So if you're thinking about you have $600 in savings and you want to buy a phone, you want to take a look at your end balance. So if you're taking away the cost of the 32 gig phone versus take away the cost of the 64 gig phone, you'll have more in your savings account if you buy the less expensive or smaller phone. So intuitively, I'm okay with that answer, and that's what I'm selecting. My savings account is bigger or larger if I select a smaller phone because it costs less money. All right, last question, simplifying expressions. This was our video from Monday. So we're just basically trying to do anything that we can that allows us to simplify these and get them into less terms. We start off here with 1, 2, 3, 4, 5 terms. Let's see if we can make this a little bit smaller. Again, remember, follow PEMDAS. He had another application of PEMDAS. Seems like that one's never going away. And it's very true, it never does. So 6x minus 2. Looks like in 6x minus 2, inside of the parentheses, nothing we can do there. So again, let's distribute. So 4 minus 12x, and that's a negative 2 here. That's going to be plus 4. And then our last step here, positive 4 and positive 4 going together, we're going to get 8. And then we're also going to get negative 12x. So positive 8, negative 12x. We just went from 5 terms to 2, so I feel good about that. They're not like terms. One is a variable, one is a constant. So that's my final answer, and that's my simplified term. All right, so quite a few skills that we just went over right there. As always, any questions, definitely let me know. I am here to answer them. But hopefully this video and the quick 1 question example per unit will give you a good idea of maybe which ones you want to look back on and which ones you feel confident with. So thanks for watching, everybody, and I will see you in class soon.